radiation at its current rate if it did that? Yes, we think so. So it's probably a combination of this contraction, and also it could be there could be the radioactive decay. But we think that the radioactive decay is probably not contributing to most of it. Yes, we are 4.6 giga years old. The appearance of Jupiter and Saturn depends on the temperature and the resulting chemistry at the highest levels in their atmosphere. So basically, the first thought that we had, so yeah, I'll just recap. The first thought that we had was, is it a bunch of radioactive decay that's happening? But we kind of thought about it in terms of our own planet's radioactive decay. And we saw that the rate at which our Earth, for example, let me read this sentence again. The rate at which the Earth is heated by radioactive decay is only a factor of 5,000 lower than the rate at which it absorbs solar energy. So the fact that Jupiter was emitting energy, that's the weird one. So even scaling upward by Jupiter's mass and ignoring the fact that Jupiter is relatively low in heavy unstable nuclei, radioactivity falls short of explaining the total energy radiated by Jupiter. So it's about kind of like taking our radioactivity and comparing, like scaling by mass and saying that Jupiter, even if it did that, it doesn't really explain the radiation we're seeing from Jupiter. But I think pretty much it's a thought that it very well could be doing a global contraction. So in Jupiter and Saturn as well, heat is generated by the global contraction of the planet. And then we did all this math to get the potential energy stuff going. And we saw that it's actually not crazy to think that it could have been contracting a little bit. And even from that contraction, because of these planets' enormous mass involved, you would actually get that potential energy release in terms of the contraction, releasing all that radiation. So now we will think about, now we're going over to the appearance of Jupiter and Saturn. Yay! I get drunk on physics. You guys are such good friends with each other. I love it. So now appearance of Jupiter and Saturn are also going to kind of depend on pretty much temperature and the resulting chemistry at the highest levels in their atmosphere, because we're not really that close to Jupiter and Saturn. So these types of things like temperature and chemistry is what's really giving us their appearance. So the rapid rotation of Jupiter and Saturn stretches clouds into bands that run parallel to the equator. Good night. So if you were wondering why there's these bands, well, there is the rapid, crazy rapid rotation of Jupiter and Saturn stretches clouds into bands that run